In Section 3, we're going to be looking at a topic called conditional probability. Sometimes when we know that something has happened, it changes the probability of things that it's related to. Like in this card game, what's the probability that I'll draw a club from a deck of cards? If I shuffle up a deck of cards, there are 52 cards total. There are 13 clubs, so the probability of drawing a club is 13 out of 52, or 1/4. Now look, if we draw a club, then it's the ace of clubs. What is the probability we'll draw a club the next time? Well, the probability of drawing a club in the beginning is 13 out of 52, or 1/4. But what if we've just drawn out a card and it was the ace of clubs? That means there's no more ace of clubs in the deck. So now there are 51 cards and 12 of them are clubs. So the probability of it being a club, knowing that we just drew out an ace of clubs, is 12 out of 51. It has changed the probability. So what's the probability the second card is a king if we drew out the ace of clubs? Well, again, just by knowing that there's no ace of clubs in the deck, there's 51 cards in the deck, 4 of them are kings. So the probability is slightly different than what it would have been in the very beginning. Here's a spinner. We've done this one before, divided into equal spaces, red, blue, yellow, and green, different numbers of each. We want to know, if we spin this, what is the probability that the spinner lands on green if we know it did not land on red. So if you close your eyes and I spin the spinner and I say, hey, it did not land on red, and ask you what's your confidence in it being green. Well, the idea is all we have to do is figure out, okay, if it did not land on red, what else are there? Okay, if it's not red, there's blue, there's yellow, blue, blue, yellow, blue, green. There are a total of 7 spaces that are not red. Out of those, how many are green? And so again, the denominator of the probability has changed. Look at this, a Venn diagram illustrating 2 sets. We want to know if the probability of A is this, and the probability of A given B. So if we know that it is in B, so if we're given B, the number of things in B would be 39 and 21, or 60. And how many of those that I have colored are in A? That would be the 39. So that is the conditional probability. The vertical line is read given. Probability of A given B. So here's another situation. We've got a box of balls. 2 balls are being drawn without putting any back. What's the probability of drawing a red on the second ball? I'm going to show you another handy tool for constructing probabilities. Tree diagram. So if we use the tree diagram, here's the first draw. It can be red or it can be blue. What are the probabilities of red and blue? Well, if there's 10 balls in the box and 4 of them are red, then 4 out of 10 is the probability of drawing red. 6 out of 10 is the probability of drawing blue. Now, on the second draw, we can still draw red or blue. The probability of drawing a red, if we've just taken a red out, is 3 out of 9. Blue, there's still 6 of them, so that would be 6 out of 9. If, however, a blue is drawn out first, the probability of drawing red would still be 4 out of 9. And blue, we take one of the 6 out, there's only 5 left, so 5 out of 9. Now in the tree diagram, to find the probability of drawing a red on the second draw, you just identify the branches that correspond to that. Here are the 2 branches that correspond to red on the second draw. We multiply at the beginning out to the ends of the branch, and then add those up.